Basically, the bacteria has this system called a proteasome. A proteasome is comprised of many different proteins. And what it does is it degrades other proteins. So it's kind of like a little garbage disposal in the cells. All human cells have proteasomes, and some bacteria do. The proteasome is absolutely essential to the cell's life. If the proteasome is inhibited, it can become extremely toxic. A proteasome is a protease that's kind of shaped like a barrel. It's got 4 rings. It's like 4 donuts stacked up on top of each other. And there's a hole. And the protein goes into that hole and gets chopped up, and then little pieces get spit out. This process is very similar in humans and bacteria, but the thing that gets the protein to the proteasome is very different. There's this specific protein called DOP, and I always draw it as a Pac-Man. And DOP is somehow important for getting the proteins to the proteasome.
And it's super specific to TB. See, it all starts with this 64 amino acid protein called PUP. Now, the last amino acid on PUP is glutamine, Q. Now, glutamine needs to be transformed into glutamate, and it's done by the Pac-Man, DOP. And now, glutamate is ready to join with the proteasome's accessory factor A, half A. Now, they're ready to meet up with the doomed protein. They send the doomed protein on its merry little way to the proteasome. They put it down the middle, it gets chopped up and spat out at the end.
I think the proteasome in TB bacteria have many different functions, but its ultimate function, its very primary fundamental function, is to degrade proteins. So what then happens if it can't degrade those specific proteins? And how does the proteasome even choose which proteins to degrade? If we can further understand the mystery of the proteasome, we might be able to develop medications that specifically attack it, and therefore more quickly kill the tuberculosis bacterium.